This is the second exam review video for Chapter 2, Part 1. So you're in equation solving mode at this point. So on number 15, I would distribute that 2/5 because again, our plan from before, if you watched the last video, was to simplify on the same side. That means distributing, and on same side, combining any like terms. Then going and solving by undoing operations starting from subtracting and adding. So as I go through this one, the 2/5 needs to distribute to x and to 2/5. You have a couple options here. 2/5 is the decimal point 4, so that would be a great way to change this problem into one that might feel more comfortable. You can also leave it as 2/5. I'm going to do it as a decimal because I think more of you are comfortable there. So distributing, I'd have 4/10 x plus. When I distribute that one, I'm going to get a 1.2 is 10. Then from here, SADMEPs start to simplify. We already simplified, so start to solve on both sides. Number 16, I'm looking through this to see what I need to do first before I just start calculating, and I see a distributor of -8. So I'm going to go ahead and start to simplify that side, but again, bringing down the 7x. Then -8 times x is -8x. -8 times 3 is -24. 1. I'm not done simplifying because on the same side I see something I can simplify. So 7 minus 8x is -1x. Now I see that left-hand side simplified, so I want to be sure I start my SADMEPs now. How can I add, subtract to start to solve this? So an add 24 to both sides. But the number one mistake people make on this one is that they'll drop that negative in front of the x, and I don't want to do that. There's still a -1x there, so I'm not completely finished solving this one. So I divide both sides by a -1. The negative ones will cancel and make a +1x, and the other side will become a -25. All right, when we get down to 17 and 18, you have distribution on 18, but you're going to end up with x's on both sides. You can't combine those because we said same side, simplifying. Opposite sides, you have to use SADMEPs. You have to undo by adding and subtracting. So on this one, it's like canisters. I see 9 canisters on this side and 1 canister on this side, so the only way I'm allowed to pull those off is if I take the same number of canisters off both sides. So in this one, just to get you going, we should end up with 8y minus 1 is -25. Finish solving from there. 19 is a word problem, so again, we're going to read through it, checking for things like rates and beginning amounts or ordered pair information. Suppose you already have $55. That sounds to me like a starting amount, but let's read through and see. You earn $9.25 per hour. You earn $9 per hour. That sounds to me like a rate. How many hours must you work in order to have a total of $225? This sounds like an amount that I'm building up to by adding things together. So we've done equations before with rates and starting amounts, and we might want to tie that idea back to it. $9.25 per hour is money per hour. That's my rate. That's my slope. You already have $55. That's where I'm beginning to start saving from. And I want to add those up so that I can get a total of $225. I think that's my y, what I want to output. So I want $225 to come from my rate times the number of hours that I'm going to work, and I don't know what that is yet, and add the 55 that I started from, solve from there. And finally, 20, 21, and 22 are about having one solution, none, or many. So remember that one solution you've done a lot of. You actually get x equals a number, or y equals a number or z, whatever it is. Infinitely many solutions, we've had this before. Your variables are going to zero out. Variables are gone. But what remains is something that's true, like 7 equals 7. 0 equals 0. Then I have lots of solutions to that. A no solution, again, my variables are going to disappear when I try to solve it. My variables will be gone, but what I'm left with is something false. 12 equals 7. If I'm left with something false, then I'm going to have to say no solutions. So as you work to solve each of these, that's what you want to look for. So I'm going to go grab 21 and start to distribute. And I get 2x minus 10. And I have on the other side negative 10 plus 2x. My first thought is that since I have x's on both sides, like canisters on a scale, I want to take them off. But what I'm starting to realize is that's going to make all my x's disappear. And I'm coming over here, and my left-hand side is negative 10, and my right-hand side is negative 10. So I have one of these unique situations where I didn't get a single solution, but my variables are gone, but what I'm left with is true. So this particular equation has infinitely many solutions. And you want to pick up and finish the rest from there.